Okay, I'm recording. So I'm just doing a screen recording in case Jeff can't come back in so he can take part, or at least listen. All right, let me go back to this sheet here.
I'll just tell him we'll call him back in a few minutes.
Okay. So I do need some help. I'm planning on trying to provide a baseline, or at least a skeletal structure of all these documents, but I'll probably try and tap Subutai and Jeff for some of the text, and maybe you guys, if you're interested, they'll all be on the wiki, so they'll be freely editable by anybody. And I would like this to know if, as we go along, if you guys think of any relevant links, external sources, research papers, or whatever that would be relevant, feel free to populate these wiki documents with that stuff. So open questions. So in addition to some of Francisco's questions, and I'll get to you guys too, because I'd like to get your input. But for me, my main question is, and I think this is going to be a big question for the community, is there's only going to be so much we can do with one CLA in the NLP space, and I have a feeling somebody is going to attempt to link some together into a hierarchy. Should we try and theorize how to do that technically and give guidance around that? That's a big question for me. Is it possible? I know it's possible because I've seen, the guys in Mexico have done that with our old framework.
Yeah, and we definitely did it before with Vision. I guess from our experience with Vision is you wouldn't want to link things into hierarchy until you have one level working well. And there's two different sides of it. One is kind of the software and the tooling to hook things up. But the other side of it is actually having things working well. And the hierarchy is, if the lower level is not working well, the hierarchy is just not going to work well.
Right.
And so I guess I'm a little. I'm sorry?
We don't know that.
We don't know that.
Okay, let me go. I'm going to scrap this doc so we can talk now.
No, I was just saying that if you assume that nothing good will happen when you connect CLAs up into hierarchy, that may not be true. You know what I mean? There could be some emergent result as just simply as a result of connecting up hierarchies in some particular way that is going to encourage it to work.
Yeah, there'll be something will happen. But and
I see it very closely related to Vision, in fact.
Yeah.
As long as, and again, I'm just speaking about our SDRs that we use. The reason that they have sort of a topology in what they represent. Yeah? So it's not a random position of points that stays consistent, but you have a distribution of points which has so to say a 2D topology. And in this topological approach, I could see, so to say, a way to linking up hierarchies pretty similar with the approach of using fields, so to say, that get more and more condensed on a topological way. More or less the way how it worked for the picture demo a couple of years ago that we produced. There, I assume that you have really sort of a pyramid of pixels that constitutes the hierarchy. So this, I could imagine that this could work, so that you say, I don't know, the first level takes in something like 3 times 3 or 5 times 5 pixels into one CLA, and then to go to the next hierarchy level, you take again the CLA outputs that are arranged topologically. Yeah. All other approaches, I have to confess, I have no idea how this could be done. Yeah. So and the second question is the question of the prediction, which I'm not precisely aware of how it is implemented right now. But potentially we would need another tool in your list that you have showed before, because if the CLA, even with one layer, is capable of creating a prediction. A prediction will be, so to say, I would expect it to be a synthesized SDR. Yeah, so it's not necessarily an actual SDR as we have in our list. It could be something that differs slightly from that. So what we would need in terms of a tool is the conversion back from the predicted SDR to see what word it actually represents.
Mm-hmm.
Because the way how I understand it, every pixel in the output SDR is, so to say, computed. So it's not, now we have, I think, if I remember well, some 2,000 words that we have in the corpus. So we have an SDR for every word that occurs there, but you never know if what the prediction outputs would be actually one of those 2,000 SDRs. Yeah?
Right.
And it could still be true, because as it is arranged topologically, it could be, so to say, similar to one of the 2,000 words, but it could be, in the end effect, a different word. So it would make sense to have also the tool for the back conversion to see what the actual output represents in terms of words.
Mm-hmm. I think one thing that would be very useful for me, and maybe others, I don't know, but just sort of crystallize what is the task. Are there a couple of example tasks that we can, concretely specify that we think would be good challenges? Is it predicting the next word? Is it predicting the next category? Is it saying whether a sentence is grammatically correct? What is the actual task? What are a couple of tasks that it would be useful to do here?
I have a very fundamental approach. I mean, I have to say the development of the set SDRs was actually, so to say, stimulated by the fact that the HDM technology has developed. Yeah? So for me, the question was, how could I find a way to feed in text in HDM at the time?
Yeah.
So I have to confess, I have a very basic interest of simply demonstrating that the network is actually capable of learning word conditions. So as I put this in the notes that I sent you. I would even, so to say, compare it with a set of random SDRs to see if there is a difference if I feed. So what I would propose is for the 2,000 words that we have converted, that we also, or I could provide you with random SDRs that could be fed in exactly the same way. And what I would hope to see is that after training, the prediction for the real SDRs should be much better than for the random representation. Mm-hmm. And to me, this would prove two things. It would prove that there is something encoded in the SDR on one hand, and on the other hand, it would prove that the CLA is able to learn the transition of such SDRs.
And when you say the non-random SDRs work better than the random SDRs, what do you mean by work better? What is the metric?
That either they need less repetition to learn, or in a general the output is more correct. Yeah. So if you say to test the whole thing, we have, let's say, a list of 100 sentences where you take sort of 5 consequent words. Mm-hmm. You feed them into the trained network, and you ask for the prediction of the 6th one. And then you simply count how many of the 100 sentences the prediction was right, how many times. Yeah? And I would expect that using the real word SDIs, we get somehow a higher degree of correct answers than by feeding random SDRs. So that would be, so to say, sort of a baseline to the whole setup. Mm-hmm. More or less. Yeah.
Jeff, are you online now?
I am. I'm now walking into this. So sorry for the problems there. I just obviously joined in again. But if you're training on the same, just make sure I understand. If you're training on the same, on a corpus and you're trying to test on the same corpus, then a random SDR will work just fine, right? What you really want to do is see that the CLA generalizes and predict attributes, the correct attributes of words novel test. Are you guys discussing that or no?
No, but I was going to ask the exact same thing. Learning a specific sequence, memorizing a sequence, random SDR will do just fine. It's really, that's why I was asking the question of how do we know this thing is actually doing something reasonable?
Yeah.
Yeah.
So that's really the trick. The trick is you want to pick the correct attributes of the next word, not the next word. And this is what I was a little worried about Fergal's, I think it was Fergal's email, where he said your client got that some of your encoding, Francisco, for words that were similar didn't have much of an overlap. Because the whole point was trying to predict the semantic attributes of words, and if two words have similar semantic meaning, they really need to have semantic hopes, they have to have a bit overlap between them. So that made me, just put a question in my mind about how well we're able to do this.
Well, I think they do have the overlap. The problem is you cannot just take the sum of overlapping pixels as the measure for the overlap, because it depends on the word, how many meanings it has, how many pixels are there to overlap.
Yeah.
That's why I answered that generally that's what the SDRs are already doing. They have overlap, but in a specific environment where the meaning is actually overlapping.
Okay.
Yeah.
But can we agree that the way to measure the success of this would be some sort of measure of predictability with novel sentences maybe made from the same corpus of words, but sentences that it hasn't seen during training? Does that sound...
Yeah, well, that's the ultimate goal, I think.
Yeah.
I don't know if you can share this with us, but when we started thinking about this a long time ago, we were even just trying to predict points of speech, like, we should have a verb next, so we should have a noun next, something like that. The whole idea is just to say, what can we say about expectations in a novel situation?
Yeah, so I also think that this would be a second step after we have the confirmation that it actually. And again, I think there will be a difference between random patterns and non-random patterns, at least in the amount of training effort you have to put into this.
Why do you say that? That's not obvious to me.
Because that's the same thing as if you know this experiment where you put on these glasses that make you see everything top down, and after a couple of days the brain adapts to this, so to say, and is able to see the picture clearly again. If you do this in an extreme fashion and you, so to say, randomly reconnect all the pixels, I think by losing the immediate topology, that the algorithm has more problems in actually catching, so to say, the important parts of the information.
That's a good answer.
That was a boss.
Yeah. I can make the counter argument that with non-random SDRs, if you're learning very specific sequences, random SDRs will actually work better because there's going to be a lot less overlap from one word to the next, and so there's much less chance of it being confused.
I agree. I agree. I think it's going to happen.
You are so certain that you don't think we need to do an experiment about this?
We can do it. In fact, it'll be very easy because we already have a test in there that trained the temporal pooler on random sequences. So we could just generate some we could use that code base as a baseline. If you really want to test it, I think it'll be very easy to test it.
At least personally, I would be really interested in trying this out.
This is what he's talking about.
I think as a general rule, I think what we ought to do for this thing is come up with a series of small tasks that are educational and illustrative. And to me, the ultimate goal is to have this thing learn the semantics and make predictions about novel sequences. But I think maybe coming up with a set of small tasks that we may have expectations about results, we can sort of test them along the way, might be the right way to go. You know, so doing a test of random versus non-random would be an interesting thing to do, even though it may not be that instructive. But I agree with Subutai. I'm pretty sure the CLA will learn specific sequences better with random SDRs because it's not trying to generalize at all. It's just learning sequences.
Okay.
Yeah, just another suggestion is that the goal of trying to predict the next word is a much more difficult goal than anomaly detection, where you substitute the right word for either the wrong type word or a distant word in terms of meaning. And you know, I think it might be easier to, you know, that's one of the kind of smaller tasks that Jeff's talking about. Yes.
You're saying it's harder to predict the exact word?
It's harder. Yeah, I mean the thing is, like, if you're just going to memorize some text, that's something that you can do, right? Because all you're doing is you get the words as an identifying label for each word, right? So and what you're doing then is you're learning, you're getting it to remember or learn the actual sentences that you speak.
Yeah, I like that task. That's an interesting one. I think you could train it on all sorts of.
What I'm suggesting is that if you try and get it to learn sentences in general using this kind of mini corpus, mini language, the test to see if it's doing that is if you put in something that is either grammatically incorrect, the words are in the wrong order, or that it's just nonsense, that it comes up with an anomaly detection for that.
Yeah,
right? Rather than trying to predict the next word, because trying to predict the next word is like the learning the tunes that we had the last hackathon.
Yeah,
It's just actually learn. It's not teaching it music; it's teaching it to learn this one song.
Yeah, I think that's a really good idea. I like that idea. You know, we could.
We would not need to have word SDRs. It would be sufficient to have sequences of post tags. Basically, you could simply convert sentences in the post tag in the part of speech tags, and then you train the system on the part of speech tags to know if it actually detects something that is incorrect. You don't need the actual word for this.
I think it's a different question, right? Ideally we want to do both, right? But what we're doing when we're doing natural language processing ourselves is we're using the words as placeholders to create sequences which represent concepts, right? Now the individual words are to some extent interchangeable. That's why I was using, big, larger, huge, etc. They're interchangeable but by degree. And a sentence containing those words has an analogous meaning with a variable that changes depending on exactly what word they're using. Yeah. So what we're going to try and do with the purpose of your SDRs is to encode to some degree that meaning, rather than being a one-for-one symbolic identifier or just a totally random label for a word, right? Okay, because the thing that we're doing is not processing the words as tokens, we're processing the meaning of those words. Yeah.
Yeah.
And what we're trying to do with this project right now is trying to figure out, can we get the CLA to interpret the meaning of the words, right? And the way to do that is to basically test to see, does it detect a genuine, appropriate sentence, having seen a number of genuine, appropriate sentences using a small corpus of words.
So Could I try out two different tasks that try to crystallize what you're saying? One is, we would feed in lots of sentences from a known corpus of words, and then feed in novel sentences that are grammatically correct, and we should see low anomaly scores. If we feed in novel sentences that are non-grammatical, we should see high anomaly scores. That's kind of a syntactic test. And then a more semantic kind of test would be, we still feed in sentences that are grammatical, but where the categorization of the words is completely wrong versus correct. So instead of I ate an orange, it would be I ate a bicycle. And that if we have done a good job with our SDRs and the SDRs actually encode meaning, we should actually see anomalies if someone says I ate a bicycle. Yeah. Is that?
Yeah, but I think in the basic configuration, when I was talking on the fact that we also need the back conversion. So maybe an example could illustrate this. So for example, if we have a sentence, the man is driving the car, and we have the CLA learn this sentence, what I would expect when I ask it and I say, okay, I give you the man is driving, and the answer could be something that ends up being automobile. So it could be a word that is not actually part of the training corpus, but if you back convert the pattern that the system gives you back, it will turn out to be automobile, because automobile and car share in a specific area a certain amount of pixels. That's what I'm hoping. Because all the other aspects, sorry.
I think that was consistent with Subutai said, right? I mean, you said, or maybe, is that right, Subutai? Is that consistent with what you were saying?
Yeah, it's very consistent, I think, and it takes that another step, I think. Instead of just looking at anomaly scores, also doing the conversion back to actual words. So we need some way to map the SDRs back to words.
Yeah. And that's what I meant when I compared this to the random patterns. If you feed in the random patterns, what you will find out is that you will get a pattern that has 80% of the dots similar to the random dots that you have for the word car, but it will not allow you to actually see what the word would be. That's the difference to the random patterns.
So,
you can do that in the classifier. And by the way, so that basically, you tell it to predict, you add in an extra field, which is the actual word.
Yep.
You know what I mean? So like basically you get it to keep track of, I mean, effectively you have a list of categories with 2,000 categories in it or something like that. And, or come up with some other indexing scheme to just encode the words.
Yeah, we actually
are
we have our category encoder. I mean, it does random SDRs, not the SEP-like SDRs, but it has that capability already. You can, associate an arbitrary text with an SDR, and then when you're predicting that SDR, it'll map it back to that text. And we just need a version of that works with the, SEP-like SDR or some non-random SDR.
By the way, for this to work, you have to train multiple sentences. You have to say the man drove a car, the man drove a bicycle, the woman drove a car, whatever, because it has to see which the bits of the words are important to associate with, and which of the bits are not. So some of the meanings of car will not be persistent across driving scenarios. So I need to have driving this, driving that, before it'll learn the right attributes.
Okay.
Yeah.
Yeah. Yeah. So that's why I said and also a variable is also the learning scheme. How many times you expose it, are you exposing the text sentence-wise, how many times you repeat to expose the sentence to the CLA and so on. I think this is a big variable. And again, I think that the better the semantic encoding in the actual SDR is, less effort you need in sort of repeating the different examples. But fundamentally, of course, you need to repeat and have several points of views.
My problem is it's not important to repeat the exact sentence. It's important to have semantic similar sentences repeated.
Yeah.
If you just repeat the same sentence over and over again, it's going to learn it like just like a series of meaningless association.
Yeah, so we will see if there is still the possibility that our training corpus has not sufficient variability. But again, I think we have to start and investigate it, but because I could not give a guess on if that is sufficient or not.
So here's a very simple, just go with it, a very simple experiment. You train on one type of thing, Tom drove a car, Tom drove a bicycle, Tom drove this. You train on 20 different Tom drove things, and then you show it, Tom drove another vehicle with a handstand, or Tom drove a banana, and it should have less of an anomaly when that novel vehicle. It should have picked up the attributes of cars that are unique.
That could be a specific task also. I mean, it would need an extra, so to say, test set you need to craft a test set for this, but that could be a good NLP task. But it's more about classifying, so to say.
Yeah, I think we can start with your set SDRs, but just come up with 20 sentences that they manually create. And I think these are the kind of small examples we have to work with because it to be very tangible, make sure it's working, understand it.
Okay, well, that sounds like a very a task that could be, very simple to do or potentially doable in a hackathon kind of setting.
Yeah, that's what I'm thinking. I think we need to have small, bite-sized tasks that people can accomplish, report on, understand, and time to debug and analyze.
It's also one that you can expand quite a bit later.
There was a question about whether the set SDRs are all the same sparsity. Are they, do you guys discuss that or not? Do they all the same number one bit?
No, they are limited in the density. So there is a maximum density of 5%, but the density below 5% is relative to the word frequency, so to say, in general language. So there are rare words that have much smaller, I mean, they have much less ones than other words. Yeah. But it's cut towards with 5% maximum fill rate.
So this to me might be an issue. If they get, I mean, the theory requires sort of a relative constant sparsity. It's not that, but it has to be relatively close. So if you went from 5% down to 0.5%, I think it could be a problem. This is what I was suggesting in my earlier email, that there might be an exercise of taking those set SDRs and running through the spatial pool and trying to create new SDRs that are constant sparsity. I think you might need to do something like that. Does anyone agree with me on this? Or yeah, absolutely. Yeah.
So we have a task for that to create a pass-through encoder, which would do that, correct? So
no, I don't know if it'll do what Jeff is saying. So, well, we could, yeah. We could then pass it to a spatial puller. You're right.
So we could have an encoder that produces a sparsity.
Just take the set SDR and that'll be it.
Right.
So, I mean, what we need to do is, if you run it through the spatial puller, it will convert it to an SDR that's, roughly 2%, or whatever it is.
Now, how important, Jeff, do you think it is to have an exact fixed sparsity level? Because in the vision networks, it would vary a little bit too, depending on the image. I don't think we.
A little bit's okay, but I think that if you go from 5 to 1%, I'm guessing it won't be okay.
Yeah, that's a.
You're going to go from 5 to 4%. That's probably fine.
Mm-hmm.
And would this also be true if we would feed the SDRs in an ordered way? Because what we can say is that there are always some ones. There might be very few, but there will be always some ones. Otherwise, the word would not be part of the retina. But if we have, so to say, arrange the input layer in a 2D manner, we would still always have, so to say, some columns that would get sufficient, so to say, trigger to basically become active.
Well, it's a good question, and I don't know the answer to it. We might need to, this could be another task. But I have to spend some time thinking about it. But because, up to now, we've always done this with sort of fixed, relatively fixed.
Yeah, I would think.
Sparsity.
Yeah, I think if we have a topography, then in any kind of topographical area, you'd want some, close to fixed level of sparsity, because otherwise the temporal puller is just not going to be able to learn the sequences. There's going to be, there's going to be some threshold number of synapses that have to activate in order to activate a particular cell in the temporal puller, and if the number of active synapses varies dramatically, I don't know that it's going to be able to learn sequences very well.
I guess if you have a large enough potential synapse space, it would probably work. But I guess I'm comfortable with that. I'm not sure.
Yeah.
I think it's something it's an assumption that it's going to work, and if it obviously gets too sparse, it won't work. So what level of range of sparsity will work, I don't know.
Yeah, I mean, I imagine that it's like in vision, if you have just a small light spot somewhere in your vision field, you can detect it. You don't need, so to say, an overall level of gray to be aware that there is a light spot, simply because it analyzes the input in an ordered way, an ordered 2D way.
Yeah, but a lot of it's done by the retina. So the retina will adjust light level, so on. And it's a lot of the sensory processing, which is what we're talking about here. That's what you guys are doing. And you're creating a sense, the word.
Yeah.
So, that's another very good, simple, small experiment. Train on a series of accept SDRs, learn the sequence, and we'll learn it. I mean, there's no question you can learn the same sequence. And then you can try it by running the SDRs through the Spatial Folder and creating a more uniform SDR, and then train on that sequence and see how it performs differently.
Okay.
Which one learns better, or can you learn on the first one? That kind of thing.
Yeah, yeah. I mean, we could even provide the specific data from our side, because typically our SDRs are, so to say, sparsified down, because the generic data is much denser than it is in the actual SDR that we deliver. So we could, for example, make a conversion where you have SDRs that are built from, let's say, 50 to 99%, and then you can use the spatial puller to actually pick so to say, specific bits out of a pretty full. Yeah, so just to make the experiment easier.
So it would be almost like feeding in a grayscale image rather than a binary image. Is that what you're thinking? Or?
Yeah. Yeah. So the original data is like a grayscale image of the SDR.
Yeah.
That sounds good.
Yeah.
So would this be a good time to? I've been taking some notes. So would this be a good time to kind of review those notes? And I've also been taking some tasks down that may spur some further conversation, which is fine. We have time here that we can continue speaking, but it could also we could also wrap up. It's up to you guys.
Well, I just let you know that so far I've been on a ferry, I've been walking, I've been on a tram, and now I'm on a train. And the train's going to go fast, so I might lose your cat. So.
Yeah.
Okay.
But Jeff, you're a living example of this particular task that we were talking about. Jeff rides a bicycle. Jeff goes on a ferry. Just don't drive a banana. Just don't go on a banana.
That's correct. Very good.
Okay. All right. So Jeff,
I'd love to hear your review.
Okay, if you miss it, I am recording this, at least most of it I've been recording. So these are just some random notes that I've taken. One is to somehow provide a back conversion from the output of CLA to translate the output back into an SDR, into a word. I know Sept has an API to do this. One open question is, does that endpoint return the closest quote-unquote word to the input SDR, or does it have to be an exact match?
No, that's precisely the advantage. It delivers the closest word it can find based on Euclidean distance.
Cool. Yeah, so there's going to be one thing we'll have to work through when the temporal puller is making predictions. You know, if it can make multiple predictions that are simultaneously encoded in that SDR. So it will OR together a bunch of different words if it's trying to make a prediction. So with that kind of a representation, will this be able to return back, you know, some reasonable word? Or
that'll be a really interesting experiment.
My guess would be that you find all the different predictions in the sequence of the similar words to a given SDR.
Yeah.
So you don't know which one it would guess will be the next, but you will see that there are a number of center of gravity within the representation. Yeah.
Okay. So the results of this back conversion could actually be outside of the input language corpus, which is fine. To provide a baseline for some of the hackathon, we could do a random word SDR input versus a known word SDR and do some comparisons along those lines. Or another one is train it on lots of sentences and then start feeding in unknown sentences versus known sentences, just to provide some very simple baselines. For anomaly detection, we could provide some guidance. I think that may be the most successful area of this, because we seem to do rather well at anomaly detection. So it's probably easier to do than prediction. So we could, after training on sentences from a known corpus of words, feed in some nonsense sentences, and we should see high anomaly scores. Another idea along those same lines is several sentences like Tom drove in X, where X is all a set of reasonable words. Train on lots of those reasonable sentences and then start sending in unreasonable values, again, to confirm high anomaly scores.
And I think that...
that was potential. If I understood the previous task wouldn't work unless you did that for the similar sentence thing.
Yeah.
Yeah, okay. So,
I would say maybe we could categorize it into syntactic anomalies and semantic anomalies.
Right, right.
So two different types.
This would be a syntactic anomalies.
Yeah.
And I have a practical question. Sept SDRs are larger than our current CLA implementation. So do we have to do a different build of the CLA for this?
No, as long as you know, all those numbers are just parameters when you run your scripts. So it's not hard coded.
As long as people know that.
Okay. Yeah, that was also one of my questions.
Yeah. There's actually a lot of things to discuss there about what should be the right numbers, but let's not get into that here.
So then I have a list of tasks to do. Some of these are, so one is to test results of random word SDRs versus real word SDRs and compare and make sure that, I think that's...
I have a question to this. So the goal is to make this before the hackathon, to have this baseline.
Yes.
Is right?
I think we should at least provide that before the hackathon.
Okay.
We don't have to, it's not essential, but it would be, I would like to. So another task is to train on the known language corpus, then feed in grammatically incorrect input for anomaly detection. That's the same as one I already said before. Aside from, so this was an idea of mine, I don't know what you think, but aside from our existing corpus of children's text, it might be a good idea to provide another corpus of more general nouns, verbs, etc., just for experimentation, like so we could do the things like Tom drove a car, Tom drove a boat, etc.
Okay. For me to produce a list of matching words with SDRs from, let's say, I don't know, the high frequency words of general language or something like that.
Yes, exactly. And then we could create this experiment based on whatever that list of high frequency words in general language are.
Mm-hmm.
And again, this is just necessary for people who don't want to use the API because you could do this dynamically.
Agreed.
Yeah.
But it would be helpful, I think, if you created another mapping file for those very high frequency words.
What sort of size? How many words are you thinking of as well?
I don't know. How much work would it be? Like 500, 1,000? I'm just guessing.
I can check. I don't know. For example, we can take a level like when after 1 year of school, what is the vocabulary of a kid?
Yeah, that sounds good.
I can find this out, and then I take that amount because we have the frequency values of every word based on Wikipedia, of course, but that should be sort of kind of representative. And I could say, okay, give me the top 0.01%. We have 11 million terms captured, so there is really plenty of stuff. So it's like a fraction of a percent will give you kind of a couple of thousand words already.
All right, so if you give us that 0.01%, we should probably just confirm that it's reasonable. We could create a lot of different sentences out of that.
But again, the problem I see is rather in the, okay, for the anomaly detection, this should be perfect, no problem, so to say. But whenever you want to look what some resulting SDR represents, then you need actually to go to the API because you never know to what degree it actually matches with one of the words of your collection.
Yeah.
The code could be written, so if it's not in the existing thing, then it queries the API.
Yeah, and I don't think it's going to be a big deal for our participants to get an API key and use it. It's a simple API. So maybe it's unnecessary to create this mapping, but I'm sure there are going to be some that aren't going to use it, or aren't going to use the API, so it'd be nice to have.
I simply produce it and we'll see if people ask for that.
Okay. Sounds good. So I made a note that we should create an additional encoder that accepts an SDR and normalizes its sparsity for the SP to provide a fixed level of sparsity. We already have a task for the pass-through encoder, and a guy in our community, Matt Keith, has already taken that on. He says he's already created it, and he's created one that takes an SDR string as well as like a bitmap array of on bits.
I mean, something that is not clear to me is how do you define which bits of the input leads to which bits of the spatial puller. Is there a configuration file that makes this mapping, or how does this actually work?
I don't know.
Okay, so basically all the bits of the input are fed to all the input bits of the CLA, and then it's upon the synapses to decide what goes where. Is that right?
Yeah, but there's, a percentage of the bits are accessed by each column.
And they could be everywhere in the SDR.
Well, if you connect them up topologically now. So
that was precisely my question.
Yeah.
If you have to restrict this.
Yeah, well, there's two modes for the connection strategy. I'm not sure what the implementation is exactly right now, but there is, at the moment, the standard configuration is to randomly connect each column to the input. But you can also do it in a more topological fashion. Okay, and in that case, what will happen is that each column will effectively be looking at a sub area of the input, and will learn to basically activate based on exactly which bit it connects to.
Within the area, it selects randomly again.
I believe that's what it does.
Yeah. That's right. You can, and even within that, there's some parameters. So you initialize the potential pool of synapses according to a Gaussian round the center. It can be center weighted or randomly within that region. I think there are a couple of different options there. And it was more designed for vision, that part of it, so it's not clear to me exactly what we want here, but something like that should work.
Okay.
Yeah, I think we should simply define fields that are routed to specific columns in the same arrangement as the arrangement is in the SDR.
Yeah, each column has kind of if you think of it as an image, each column in the spatial pooler and the temporal pooler will have a kind of natural center point in that image, and then it will recruit bits from some receptive field or some nearby region. And then exactly how it recruits, it could do it randomly, or it could do it with a center-weighted kind of strategy.
But that's part of this spatial pooler. Is that a configurable aspect of it?
In theory, yes. I think the one that Gil is working on now, he's testing that a lot more. So I know when we worked on Vision, it was all working well. We haven't tested it recently, but I think Gil has been testing it more. Okay. Now the temporal pooler has to do the same thing as well. So when it recruits synapses for its segments, it has to look in the neighborhood as well.
Okay, so the last thing I have on our list of tasks is an experiment to train the raw SEP SDRs through the SP with just a simple pass-through encoder without mutating the partial density at all, and also train a set of normalized SDRs of the same words with fixed density to compare the results and just confirm which one is getting better results. Okay, so that's the end of my notes there. Do you guys think I missed anything important?
Sorry?
Did I miss anything?
No, in principle, I'm fine with this.
Okay.
So who would be actually doing the pre-experiments?
Who? Well, that's yet to be decided. Most of this stuff, I think, is entirely appropriate to relay to the mailing list, and so this is kind of our plan for prepping for the hackathon. I would like to get participation if anybody wants to take tasks on, as long as we define them well enough that they get accomplished in the way that we want them to. So I could provide these meeting notes in a list, in a message to the mailing list, and say, we kind of had a planning meeting for the hackathon. Here's a list of tasks that we'd like to accomplish, create tickets for them in our ticket tracking system, and see if anybody is up to the task of taking some of them on.
Okay.
If not, I'll make sure that they get done one way or another.
Somehow.
Then you switch to different methods.
Yes.
Yeah. Well, there's top down and there's bottom up, right?
We'll try bottom up first and see how it goes.
Yeah. Okay. Cool.
Okay.
Good.
This has been a very fruitful call. I really appreciate your participation and your help planning this event. Really excited about this, and thank you very much.
Okay. Thank you.
Okay.
Thanks.
All right. Take care.
Okay, take care. Read you soon.
Yes.
Are you still got Friday to do?
I do.
Yeah, we still have to work now. You can relax.
All right, have a nice weekend.